Hey, welcome to our new topic. Now we're studying probability. We're changing the scope and sequence because everything else has too much prior learning, and so we're going to start with probability. Now, probability is, in my opinion, one of the most hectic things, but topics. But the advantage is we're starting on something fairly simple, something that you've already done before. Now, as you can see, we're going to do the fun the mental counting principle, just to start off with. And a lot of this is kind of common. You guys will get it. It's common sense. But let's have a look at the first bit. Let's have a look at just this question. A die is rolled. What's the probability of rolling a 6? Okay, what's the probability of rolling 6? Now, straight away, most of you guys will say, oh, there's a 1 in 6 chance. But before we do that, I want to just introduce more than likely these words because we're going to use them quite a bit. That's sample space, total possible outcomes, and successful outcomes. Because a lot of, I think, probability is about the language. If you don't have the language, you can't really express it, and the language is very nuanced. Total possible outcomes and successful outcomes are things that we're going to say often. The reason being is it's looking at all the options either that can happen or all the options that we want to happen. So in this case, the total possible outcomes for rolling a die is 1 right through to 6. It's the sample space, but there's 6 possible outcomes in this case, 1 through to 6. But the only outcome we want, or the successful outcome, is the one that meets the criteria. In other words, that rolls a 6. So then we look at, well, what exactly is probability? And probability, if you think about it, what is the chance of this happening? It's a 1 in 6 chance. Well, that's just the number of ways the event can occur. In other words, the successful outcomes divided by the total possible outcomes, which is one possible outcome, or should I say one successful outcome divided by 6 possible outcomes. Let's add another level of complexity. So if I say a die is rolled twice, okay, what's the probability of rolling 2 6s in a row? Now, some people get this, or I expect you guys will probably be able to do this, but this brings in another really, really important point, and that's basically what we're doing today. The probability of successive events is the product of the probability of each individual event. So in this case, the first event, the probability of rolling 2 6s in a row is the probability of the first event, which is 1 6, times the probability of getting a 6 for the second event, which is 1 in 6. So in this case, we have 1 in 6 multiplied by 1 in 6. So the chances of rolling 2 6s in a row is 1 in 36. It's only one chance out of 36 of getting 2 6s in a row. So now let's link that to the fundamental counting principle. That basically was it in a way, sort of, not really. Let's look at a context. So Cassie needs to catch a bus and a train to work. There are 3 different buses she could catch into town. When she arrives into town, she needs to catch one of 4 trains to work. So if there are 3 buses and 4 trains possible for Cassie to catch, in how many ways is it possible for her to travel to work? Now, I suspect that you could probably do this, but let's put this in the context of the fundamental counting principle. In this case here, if she goes on the A bus, she can go to then on the first train, on the second train, on the third train, and then on the 4th train. So if she catches the A bus, there are still 4 more possibilities. B bus, there are still 4 more possibilities. The C bus, there are still 4 more possibilities. So in total, there were 12 different routes that she can take. Now, the fundamental counting principle says if one event can happen in A different ways and the second event in B different ways, the third event can in C different ways, so on, then the successive events can happen A, B, C, and so on different ways. Let's put that in a nicer way. I like basically saying, well, let's say each event is a space. How many options are there? So the total possible outcomes. How many options are there in each event? And I actually just put a line in. Okay, so in this case, if she catches the A bus, how many more options are there with the A bus? Well, there are, what should I say? How many options are there with the buses? 3. How many options are there with the trains? 4. And so 3 times 4 equals 12. In other words, the total options for the first event and the total options for the second event. That wasn't the clearest way of explaining it, so let's do one in context. So let's look at this question here. If the number of plates on a car has 2 letters followed by 4 numbers, how many different number plates of this type are possible? And so in this case, if I was to do this way here, I would write down the total possible outcomes is the first letter, the second letter, the first number, second number, third number, fourth number. So how many letters are there possible? That's right, there are 26. How many letters are there possible for the second? Well, you can have repeat letters in a number plate, so there's another 26. How many numbers are there possible? You can have 1 to 9, but you can also have 0. So there's 10 here, and there's 10 here, and there's 10 here, and there's 10 here. So these are all the different options that we can fit into each position. So the total possible outcomes is each of these multiplied by each other. And so in this case, how many different number plates are possible? 6,760,000 possible number plates or possible outcomes in this case. Here's another question. Pause it and have a go at this yourself. I'm pretty sure that you can do it. Okay. So a restaurant serves 5 different types of entree, 12 main courses, and 6 desserts. If I order any combination of entree, main course, and dessert at random, how many different combinations are possible? Okay, let's have a look. So really, we've only got 3 possible things. We've got entree, we've got main course, and dessert, and all of these multiply together. So how many entrees have we got? How many main courses, how many desserts? We've got 5 times 6 times 12 times 6, and therefore there are 360 possible combinations. So the next question says, if my friend takes 3 guesses at which combination I will order, what is the probability that she'll guess correctly, assuming that all of them are equally possible? And we see the probability is the successful outcomes divided by the total possible outcomes. And so if she's guessing 3 times, then she's making 3, there's going to only a chance of 3 successful outcomes out of a total of 360. Therefore, the probability is 1 in 120. So the fundamental counting principle is just how many outcomes can I do? And we do that by finding each individual outcome or event, outcomes in each event, and multiplying them all together.